All right, 6.4a. For this lesson, we're going to be factoring polynomials. We have done this for certain cases up to this point. We will have two new special cases, okay, and these are called difference and sum of cubes. Okay, so again, we talked about perfect squares before. So like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Okay, and then with the variables, we're looking for multiples of 2. Okay, those were perfect squares. Now we're going to look at perfect cubes. Okay, so my perfect cubes, 1 cubed is 1, 2 cubed is 8, 3 cubed, 27, 4 cubed, 64. Okay, so those are perfect cubes. Okay, and we can go on and on with that. But when we look at variables now we're looking for exponents of multiples of 3. Okay, so those are examples of our perfect cubes. Okay, and then the red, perfect squares. Okay, we did get pretty good with perfect squares, but now let's go beyond and do those perfect cubes, and there is the general form for those cases. All right, but before we get into those, let's do a little bit of review. So the first thing, again, when we're going through factoring, the first thing you always do is look for that GCF, the greatest common factor. Okay, from there, once you have the greatest common factor out, that's where we look for our special cases. And again, we have those difference of squares, and we're going to be adding those difference and sum of cubes. And then finally, the third step is just those basic trinomials. Okay, so if we look here, first one, common monomial factor. That's when we're pulling out that greatest common factor. If I look at 8x and 16, 8 goes into both of those, so I can take out an 8, and it'd be 8 times x plus 2. Okay, difference of squares. Again, that's where we're looking at both terms. Okay, what am I squaring to get x squared? I square x. What am I squaring to get 9? And again, first term, second term, opposite signs. Okay, perfect square trinomials, that's where we just factored just like we normally would. And in these cases, that's where both factors were the same. Okay, that makes it a perfect square. And then finally, the perfect, or just a general trinomial. Okay, we take out the greatest common factor. What am I multiplying to get that x squared? How do I multiply and get 6? In this case, it was 3, 2, and my signs would be plus. Okay, so those are the ones that we've done up to this point. Again, that the one in our toolbox, those are going to be the new ones. But before we get to that, again, let's just factor some ones that we've already done. This first one, okay, again, we look for a greatest common factor. There is none. So in this case, and it's not a special case, okay, so this one, it's just a perfect square trinomial, x, 2 times 2, and we are adding both of them since both signs are positive. Okay, so that's that perfect square trinomial. And second one there, okay, 2 terms. There's no greatest common factor, and again, 2 terms is a good indicator of a special case. And in this case, it is perfect squares, and it's a difference of squares. So again, when we do this, to square, in order to get x squared, we square x. In order to get 4, we square 2. Opposite signs. Third one there, okay, just the basic trinomial, no greatest common factor. So break it up, x times x to get x squared. My signs need to be opposite due to the fact that this one is negative and this one is positive. Okay, to multiply and get 4, 2 times 2, or 4 times 1. 4 times 1 is what's going to get me 3, and I need the positive to be 4. Okay, so in that case, x minus 1 times x plus 4. Here, we got x squared minus 3x minus 4. Again, no greatest common factor, not a special case. So just a general trinomial. Has to be x, has to be x. We got a negative sign there and a negative sign there, so we have to be opposite. Okay, and then in this case, I want negative 3x, so I'm going to make the negative 4 and positive 1. And remember, check outside and inside, negative 4x, positive x. Those should combine to get our middle term. All right, again, here, greatest common factor, there is one. It is 3. 3 times x squared minus 4. Now I still have that square term in there, so there's a possibility that it factors further. And I notice that it is a difference of squares on the inside. So 3 times my 2 parentheses, x, just those square to get x squared. Okay, 4, 2, 2, opposite signs. Okay, so that was a combination of a greatest common factor and our special case of difference of squares. All right, on this one, greatest common factor again, we can take a 3 out. 3 times x squared minus 2x plus 1. Okay, still got that squared term in there so that we can need to check to see if it factors further. And it does. Okay, I have a positive sign here and a negative sign here. Therefore, both signs in the factored form need to be minus. 1 times 1 is the only way to get positive 1. Okay, so outside, inside, negative x, which does combine to get us that negative 2x that we need. Okay, so that was just a little bit of review. Those are ones that we should be able to do up to this point. Okay, so now let's look at our sum and difference of cubes. Okay, so again, we always look for that greatest common factor, which in the first two we do not have. Okay, so then again, we go to our special cases. 2 terms again is an indicator that we use a special case. And then we look, now at this point, we don't look just for perfect squares, we look for perfect cubes. So in the first one, what am I cubing to get 125? That would be 5. And x cubed is x cubed. Okay, now, when we do the sum and difference of cubes, okay, it's going to be a binomial times a trinomial. Okay, and when I do this, you take the first 2 terms. Okay, first term is 5, second term is x. Okay, and then for the terms in the trinomial, what we're going to do is you're going to square the first one, which would be 25, multiply the 2 terms, so 5x, and then finally square the second term. Okay, so what you'll hear me say for this trinomial is square, multiply, square. You square the first term, multiply the 2 terms, and then square the second term. All right, now for the signs, we're going to use an acronym called SOAP. Okay, SOAP, S stands for the same sign, O stands for opposite, and AP stands for always positive. Okay, so when we do these difference and sum of cubes, you're going to hear me say square, multiply, square. That gets us the trinomial. And then you're going to hear me say SOAP. And again, SOAP is for the signs. Same sign. Okay, same sign is referring to the same sign in the original polynomial. Opposite of positive is negative. And then always positive. Okay, so there is our factored form for there. All right, so the second one there, no greatest common factor. I see that it's 2 terms, special case, and I notice x cubed, so I'm going to have a difference of cubes. It's difference due to it being minus. I'm cubing x, and I'm cubing 3. Okay, so again, difference of cubes. It's the same setup every time. My binomial times a trinomial. In the binomial, it's just those terms, x and 3. Okay, and again, square, x squared, multiply the 2, you get 3x, and then square the last term. Okay, so square, multiply, square to give me x squared, 3x, and 9. Now for my signs again, SOAP, same sign, so minus, opposite, always positive. Same sign as the negative, opposite sign for there, and that term will always be positive. All right, so the third one there, we got 64, a to the 4th minus 27a. There is a greatest common factor here. Okay, both terms have an a, so I need to factor out an a first, which will give me 64a cubed minus 27. Okay, in this case, again, I see an a cubed, so there's a possibility that inside the parentheses there that will factor further. And what I'm going to notice is that they are perfect cubes. Okay, 3 cubed is 27. 4a cubed is 64a cubed. 4 cubed is 64, a cubed is a cubed. Okay, so then from there, we have to keep our a, and then let's split up into our binomial and trinomial. Again, 4a, 3, I get that right there. Okay, those are going to be the same. And then when I move to the trinomial, again, square. So 4 squared is 16, a squared is a squared. Okay, when I multiply 4a times 3, we're going to get 12a. And then finally, 3 squared, we get 9. Okay, and then applying SOAP, same sign. Okay, so we started with the minus, same sign, opposite, always positive. Okay. So the big thing when it comes to factoring difference in sum of cubes is being able to figure out what you're cubing to get those terms. And then the binomial is just those two terms, like in this case was 4a and 3. Okay, and when I get to the trinomial, square, multiply, square. Okay, so we square 4a, we multiply 4a times 3, and then we square 3. And then finally our signs, remember SOAP, same sign, opposite sign, always positive. And it's always referring to the original sign in the polynomial. All right, so we got some more here. 64x cubed plus 27. There is no greatest common factor there. Okay, and I notice that it's two terms, so I need to figure out what am I cubing. And the way I notice that it's a cubic or perfect cube is that it's x cubed. So what am I cubing to get that? In this case, it's 4x. We're cubing that to get 64x cubed. 3 cubed to get 27. So I'm going to set up my binomial and my trinomial. 4x, 3. Okay, and then I'm going to square 4x, which will give me 16x squared. Multiply 4x times 3, which will give me 12x. And then finally squaring 3 will give me 9. Same sign, opposite sign, always positive. Okay, next one. No greatest common factor. I see x cubed, so I'm thinking difference of cubes. What am I cubing to get 8x cubed? 2x. What am I cubing to get 1? I'm cubing 1. So I set up my binomial times the trinomial. 2x, 1. Okay, square, we get 4x squared. Multiply, we get 2x. And then square with a 1. Okay, so then we have our terms. Now we just need our signs. Same sign, opposite, always positive. Okay, so again, look for that greatest common factor. There is nothing here. So what am I cubing? I'm cubing x, and a cube, 7 cubed is 343. Okay, so set up my binomial, and set up my trinomial, x and 7. Square, so x squared. Multiply, we get 7x, and we square that one, and we get 49. Now for my signs again, SOAP, same, opposite, always positive. All right, this one, no greatest common factor. I see x cubed, so I'm thinking sum of cubes since it's plus. So sum of cubes, x, and then 4. So set up my binomial times my trinomial. We get x, 4. Okay, square, multiply, square. There we have our terms. Now we need our signs. Same, opposite, always positive. Okay, so here we got a polynomial with two terms. Look for that greatest common factor, 2x to the fourth, 200x squared. I see that both 2 goes into there and there's 2 x's, so 2x squared would be our greatest common factor. And then it would be x squared minus 100. Okay. So from there, I notice that I can probably factor that further due to x squared being in there. So 2x squared. And then what am I squaring to get x? I'm squaring x. What am I squaring to get 100? I'm squaring 10. And again, plus, minus for that difference of squares for inside the parentheses there. All right, last one here. Again, look for that greatest common factor. In this case, there is none. Okay, and we got a trinomial. So now this is a little bit different because I got x to the fourth. So I need to multiply x squared times x squared. Okay, or you can do x and x cubed. But let's start with that x squared. Okay, signs I need to have opposite due to this being negative and that one being positive. And then ways to multiply and get 24. 1, 24, 2, 12, 8, 3. Okay, I'm seeing 5, so 8 and 3 probably makes sense. And then I need positive 5, so I'm going to make that 8 positive and that 3 negative. Okay. All right, so that is factoring. Other than the difference in sum of cubes is factoring we've done already. All right, a new method of factoring is called factor by grouping. Now, the indicator that when we use this type of factoring is when we have 4 terms. Okay? In this case, I have 4 terms. When we do this now, what we're going to do is we're going to look for a common factor with the first 2 terms and the second 2 terms. Okay? So in those first terms, I see that 9 goes into both 9 and 18, so I'm going to factor out a 9. And this one has 3 x's, this one has 2 x's, so I can factor out an x squared. Okay? Now, to get that, it would be times x plus 2. Now, that's just factoring out a common factor of those first 2 terms. Now, in the second 2 terms, I can factor out a negative 4. So negative 4 times x plus 2. Okay, I factored out the negative, so negative is factored out, and then 4 goes into 4 and 8. Okay, so from there, now it's like I have 2 terms here. I got this term and this term. Now I'm looking for something that's common between those 2, which would be the x plus 2. So now I'm going to factor out x plus 2 from those 2 terms, which will give me x plus 2. And then what's remaining is the 9x squared minus 4. Okay. Now, typically that's where you'll end. But I'm noticing in one of these parentheses, in one of the factors, I still have that squared term, 2 terms. Okay, so a special case, and those are perfect squares, 3x and 2. So I need to factor that factor further, so that x plus 2 is still there, but then I got that difference of squares. In the second one, we get 3x and 2, 3x, 2, and opposite signs. Okay, so let's practice a few more there. Again, your factor by grouping. So we're going to group the first 2 terms and the second 2 terms. Okay, so what can I what is a common factor of 3x cubed and 12x squared? 3x squared can come out of that. So 3x squared times x minus 4. And then the second 2 terms, I can factor out a 2. So plus 2 times x minus 4. Okay, and now I see that I have a common factor again of those 2 terms. So x plus 4 will come out of there. And then what's remaining is that 3x squared plus 2. Okay, I see a squared term here. So we possibly need to factor further. Now, they're not perfect squares, so therefore it's not a difference of difference of squares, so it's not going to factor any further. All right, next one. Okay, again, I see 4 terms. So I'm going to factor by grouping. Group the first 2, group the second 2. I see that x squared can come out of the first 2. X squared times x would be x cubed minus 5. Okay, in this one, okay, I'm going to factor out a negative 9. And that would be times x minus 5. Okay, so again, x minus 5 is that common term that I'm going to factor out. And I'm remaining with x squared minus 9. And again, we got to make sure that this does not factor further. Okay, I see that it's a difference of squares. Okay, I'm squaring x, and I'm squaring 3. So x and 3, opposite signs. So there's our factored form for that 4-term polynomial. Okay, next one. Group up the first 2 terms, group the second 2 terms. I see 16x squared goes into both of those terms, leaving me with x minus 3. Okay, there in the next term, I can factor out a -1 and leaving me with x minus 3 again. Okay, so x minus 3 is that common factor now at this point. So x minus 3, we're going to factor that out, and it would be times 16x squared minus 1. Okay, I see a squared term in there, so we got to make sure it doesn't factor further. In this case, it does, since it's a perfect square. So x minus 3. Okay, to square to get 16x squared would be 4x. Squaring to get 1 would be 1. Opposite signs. All right, last one here. Group up again. I can take out a 2x squared from those first 2 terms, and that's going to leave me with x minus 6. I can factor out a 5 out of the next term, positive 5. So 5 times x minus 6. Again, x minus 6 is common now, so we factor that out, and I'm left with 2x squared plus 5. Okay, squared term there, but that will not factor further. So there is our factored form. All right, so for this assignment, you have a book assignment. If you go under homework, it will be the 6.4a. It is a little bit longer, but factoring is one of the most important things to take out of Algebra 2. So make sure you can get through that assignment. Now, you don't need to do every single problem, but make sure you know how to do every single type. Monomial factoring, sum or difference of cubes. That's probably the big part. Make sure to do all those. Okay, factor by grouping, probably do all those. And then those ones, the last part there, those last 2 parts, I should say, do as many as you can in order to be able to factor properly. All right, that is 6.4a. If you have questions, make sure you ask. Otherwise, have a good day.